In this video, we are going to give a presentation of our course project of CS348 Computer Vision. The focus of our project is recovering realistic images from fMRI. At the very beginning, we would like to briefly introduce the background. Discovering the similarity and differences between human brain and machines is one of the major research fields in artificial intelligence. Researchers are interested in the question that whether machines can simulate and interpret the activities of human brain, which is the key to achieve brain-like computing. And the fundamental step is to externalize the human perception. In the project, we proposed a new model named DCNN-GAN to interpret the visual perception from brain activity. The forward framework we proposed, that is, from fMRI to visual perception, will help the research of the backward framework, transforming visual perception to fMRI, which is promising to help people with visual disabilities. Biological researchers have revealed that visual cortex and neural network share an important feature. They both have a multi-layer structure and extract hierarchical information from the input signal. Therefore, it is possible for us to simulate the cortex with a fine-tuning neural network. fMRI, abbreviated for Human Functional Magnetic Resonance Imaging, records the blood oxygen levels of different regions of brain, thus reflecting how it is activated. In this project, the fMRI data is given as a vector of 20,000 dimensions, each representing a cube with edges of length 2 mm in 3D space. Our work has proposed a method that uses a deep generative network to iteratively optimize the output images. They are then encoded by a deep neural network. By forcing the encoded features to be exactly the same as those of fMRI, prior model generates their output. However, it is relatively time-consuming because it uses a lot of features in order to reconstruct the images in a single step. And the fMRI data is noisy, thus making their model, which is loyal to the features of fMRI, unable to capture the essence of images. Our proposal, after extracting features from the source input fMRI, the reconstruction of the images consists of two crucial steps. That is, coarse images are first generated by a reconstruction neural network R from the decoded features, and then they are refined by a generative adversarial network. To train the network DF that extracts features from fMRI, a pre-trained encoder network E is implemented, whose outputs are preserved at the guidance of DF. E extracts the latent variable C from the ground truth images X. Here is the result of our visual perceptual comparisons. These 4 columns of images, from left to right, are correspondingly the original images, output of prior method, reconstruction network R, and DCNN-GAN. Prior method and reconstruction network have successfully captured the shape of the original images, but they sacrificed texture information. It mainly results from the fact that fMRI data is noisy and lacking of meaningful high-frequency signals. Moreover, the images generated by prior method even contains elements that are not belong to the original images. We think it partly reveals that prior method, forcing the features of reconstructed images and fMRI to be exactly the same, overfits the training data. That's all. Thanks for your watching.